Morning, everybody, or evening, or wherever you are. We're going to hold out for a minute or two for people to trickle in, and also for me to merge the pull requests that showed up in the last hour.
Lee, before we get started, do you mind if I give a few administrative updates here?
Go for it.
All right, I'll wait till everybody gets joined here, but just a few things on some changes that we're making to the way that people sign the specification membership agreement, and essentially what that means for going forward. And then just also a heads up in general that for this particular meeting, I'm going to add a password to it. We'll explain some of that stuff.
Okay, our participant list is looking stable. Had a last couple of people join in the last minute or two. And I have merged all of the pull requests to the agenda. In the future, it'd be great if all the pull requests could be up at least the night before. Sometimes I kind of scramble to get the last minute ones merged in. If anyone has any ideas to make that easier to manage, I'm open to thoughts. I could put a meeting or like a calendar event on the shared GraphQL calendar. It's just kind of a reminder to add yourself to the next agenda, if that would be helpful. I also included a link to the live notes for today. I see there's already a couple people in there, which is awesome. Okay, let's get started. Brian, I'll hand it to you for administrative stuff before I take over.
All right, sounds good. I will be quick and then I'll disconnect here. So a couple of things. As you know, in order to join one of these meetings, one of the prerequisites is to be a member of the specification. And that involves, in the past, has involved signing a document in DocuSign, which basically says, you know, I or my employer agree to the various terms of this. And then the idea is that once you've signed that, then you can open up PRs, you can make contributions, you can join meetings, etc. We looked at this process and realized that we have some tooling at the Linux Foundation that would make this maybe a little bit easier in the future. And essentially, it's repurposing the tooling that we use for signing CLAs. And in a nutshell, the way that this works is that somebody who has not signed the Spec membership agreement, if they go and open up a PR, for example, to add themselves to the meeting list for this particular meeting, if they haven't signed the Spec membership agreement, then they get a notice that says you need to go to this place, get this form signed, you know, take it to your employer, get added to the approved list, or if you're not employed or working on behalf of an employer, sign it yourself. And once they do that, then they get unblocked and they can add, you know, make changes in the repo and you know, do all the things that that they should be able to do once they've done this. The big change from the way we've done it in the past to the way that it's being done, or that it will be done now, is that this is automated, basically done with GitHub bots, so that we don't have to manually compare lists or go back and see who has signed what. So that's one change. I wanted to give you a heads up that this is coming. It shouldn't affect any of you. I believe that we can preload your name so that you're not, you know, so you're on the already approved, already signed list. But for other people who would be coming as first timers, then they would see this flow. We haven't turned this on yet. I'm expecting it to be live, hopefully sometime later on this week, or at least ready, not live. And I think probably the best way to do this would be a phased rollout where we turn this functionality on for various repos once we've made sure that everybody who's already signed it has already been, you know, covered in the approved list in the tool, so no PRs are blocked. So we'll be rolling this out I'd say probably over the next month. But hopefully, you know, again, it shouldn't affect you, but it should make it a little more straightforward when people are wanting to contribute what needs to be done in order to be able to make contributions. So that's one thing. Does anybody have any questions about this?
So it's for all repos, not only working group.
It could be done selectively. So we can turn it on for some repos, all repos, or no repos. Is essentially the way it works.
The plan would be to turn it on for most of our repos, if not all.
Once you've signed it for one repo, also you don't have to go back and sign it again if you go and make a contribution to another repo where this is turned on. You know, signing it once means you've signed the GraphQL specification membership and you're cleared for everything else. Any other questions on this? Once we get to the point of turning it on, usually the way that I do this is I'll turn it on in a test repo so that people can, you know, poke at it and see how it works. We can send out a notification too, so you can, if you want to kick the tires or if you have a, you know, specific issue that you run into, we can address it there before, you know, rolling it out more broadly. So that's one thing that I wanted to bring up. Let's see. Second thing, purely administrative. I've been going around to the various different groups that are using Zoom accounts and adding meeting passwords. Again, this shouldn't really affect you very much. Basically, just next time, probably the working group meets, there'll just be some trivial password in order to get in. We'll post that. I'll take care of updating the meeting invite, the agenda that's in the repo, and just, it'll be a password. It'll be on a separate line. The goal here isn't to keep meaningful contributors out. The goal is to keep out people who are randomly guessing Zoom IDs and dropping in on the meetings unannounced. So if you know where to find the meeting invite, then you can easily find the password. So we're just trying to avoid, the random number Zoom bombers. So just a heads up, next time you will get a note on that. And then the last thing that I have here is for the calendar, Lee and I talked about consolidating the various GraphQL calendars. He's got one, I've got one that's shared out through the foundation. We're going to probably, I think, consolidate on the one that was shared out through the foundation was what we landed on. And the reason for doing this is just we have multiple groups that are using this Zoom account at this point. One of the easiest ways to direct traffic and make sure that meetings don't get scheduled over other meetings is to have a single calendar. So I can update that link as well. We can send out notice of who has, for anybody who might have subscribed to the old calendar, I can put something on there that'll trigger a notice that, there's a new calendar link. Any questions? Anybody? All right, that's all I got.
Thanks, Brian.
Absolutely. So I will disconnect and let you folks get to business. So thank you.
See ya.
All right, see ya.
That's a good reminder that by attending, not only are you agreeing to the Spec membership agreement, as Brian mentioned, but also the participation guidelines and code of conduct. Okay, let's start, as we always do, by an introduction of all of our fine selves. We will use the order shown in the agenda file. Give that a good refresh because I merged pull requests in the last 20 minutes. And you want to make sure you got an up-to-date look at those. I'm at the top, so I'll go first. Hey everybody, my name is Lee, and I help lead this crazy group of GraphQL folks.
Hey, my name is Matt. I've been working on the specified directive.
Hey, I'm Jesse Rosenberger. I work at Apollo on GraphQL.
Hey, I'm Benji. I work on the GraphQL suite of tools and am interested in a few of our spec proposals.
Hey, I'm Jafar Hussain. I work at Facebook on GraphQL stuff.
Hello, I'm Terrence Howard. I work at ProQuest, but my contribution is from individual.
Hi, I'm Alan. I work for IBM Research. I work on an open source tool called OpenAPI to GraphQL, as well as GraphQL API management.
Hey everyone, my name is Vince Foley. I work at New Relic, and I also work on the Absinthe GraphQL library.
Hi, I'm Steven. I work at Netflix, and I'm working on a GraphQL gateway at Netflix.
Hi, I'm Evan. I work on APIs at Shopify.
Hi, my name is Andrew. I work at TakeShape. I work on a lot of GraphQL stuff over there. I'm interested particularly today about the input union RFC.
I'm Rob from First Dibs, working on the defer and stream spec.
Liliana Matos, also from First Dibs, and helping with the defer and stream spec as well.
Hi, my name is Ivan, and I'm maintaining GraphQL.js.
Hi, my name is Greg Kessler. I work at Intuit on optimizing GraphQL execution.
Hi, I'm Matt. I work at Facebook on the client-side GraphQL native clients.
I'm Morris, IBM, working on a GraphQL proxy, GraphQL management.
I'm Trevor Shear, work at Apollo on GraphQL things and Federation.
Awesome. That was pretty smooth. If your name wasn't on the agenda, you didn't have an opportunity to introduce yourself. Do we have anybody left on the list?
Yeah, I'm Gabriel McAdams. I'm at PayPal. I will update the agenda right as soon as I'm done here. I've been doing GraphQL for a while, and I've been participating in the GraphQL over HTTP subspec.
Excellent. Welcome, everybody. I would usually ask for volunteers for note taking, but I've noticed that in our notes file, there's already extremely detailed notes being taken. So it looks like we're on top of things. Benji, Alan, I assume the two of you are in there making good things happen. Do either of you need help?
Only when I'm talking.
Great. If folks can help
I'll try to
jump in the
cover you.
notes. All right, you guys are the best. This is probably the highest value thing that comes out of these is the high quality notes. Let's go over our agenda really quickly for the day. We'll take a look at past action items if there are anything open, although I think we made it through most of them. Then we're going to talk about custom scalar specifications, the query ambiguity, discussing the RFC for adding introspection shortcuts. Then we'll go deep on input union RFCs and stream and defer arguments in payload formats. Anything else we should add to the agenda for today? All right, that's a healthy list of things, so I think we're going to be busy. Let's take a quick look at open action items. There are only two, and they are ancient, which means that these are the two that sit around forever. So we will probably still make it on these in the future, but the good news is that all of the action items that we had set up in the last 2 months have been closed out. I believe they were around making sure that we had agenda item or agenda documents for the rest of the year, which I set up yesterday. There was also an action item to take a subcommittee meeting for the input union RFC, which was scheduled and happened and was a lot of fun, which I'm sure we'll talk about in the agenda. Were there any other action items that did not get translated to issues that people are aware of?
I remember taking a bunch in the notes for last month, and I don't think all of them got into it.
See what Alexa sent?
Say that again?
Oh, she just sent it to me on Instagram. Oh, I'm sorry.
No worries. Highly relevant. Let's make sure that we circle back through those and translate them to issues. Maybe we're missing kind of a step of our like merging our notes in. We should make sure that that's like an opportunity to make sure we've converted them all to issues. But we don't need to do that live. We can do that as a follow-up, and then we can just batch together any of last month's action items that we didn't get to with any that we schedule for today's meeting. Any other thoughts on action items or agenda? Otherwise, we can get started. Great. Well, I will hand it off to Matt. Take the lead. Matt and Evan, you guys can give us an update about custom scalar spec.
Yeah, I think this should be pretty quick. It got merged this morning, or the reference implementation did at least. I believe Ivan said that they were going to cut a release for that on the GraphQL JS project. But yeah, I think it's in good shape. And so I don't know what that means for the specification process, if it moves it to another stage or not yet, but I'll defer to you guys.
That should leave it on my plate to do a final editorial pass, but I believe that's enough to move it to the final stage for approval. So let there be one last action item for me to take a final editorial pass on that. But otherwise, awesome work. I know it's been a while to get all the I's dotted and T's crossed, but I'm super excited about this one. super meaningful improvement to how we do custom scalars. Any questions or comments on custom scalar spec? All right, Benji, I'll hand it to you for the query ambiguity.
Yeah, so this is really just to solicit some opinions and maybe some reasons not to do this. We seem to have an issue in GraphQL, which is that the term query is overloaded. It's used in many, many different ways. And that can make it particularly confusing when people are unfamiliar with GraphQL. It's also particularly hard to teach as a GraphQL trainer and other such things. It makes it hard to write documentation. It's just generally a problem. So the GraphQL spec refers to query quite a lot. And when it refers to query, it can mean different things. And often you need to be already familiar with GraphQL to know what it is that it means in those contexts. Sometimes we use things like query operation, and that normally means an operation of the query type. We might say things like a query error. We use things like query reuse, which is generally referring to the use of fragments and things like that. We use the query keyword, which obviously is the keyword in the GraphQL language that you would type. And then there's query execution, which may refer to the execution of a query operation, or sometimes to a mutation or subscription operation too, which can be confusing because then you might want to refer to a query operation execution. So generally, what I would like to do, what I would like to propose is that someone, and I'm volunteering to be the person, though I would be happy if someone else wanted to do it, goes through the GraphQL spec and literally clears up all of these uses of query and comes up with some solid conventions that we can use. We already have terms that we can use for these things. So we've got terms like operation, which can refer to query, mutation, subscription. We've got terms like document that can refer to the actual GraphQL language that you send to the server in order to execute your query, and various other things. So I'd probably like to get Lee to actually check over my understanding of what those terms are to make sure I'm right before I go any further. But what I wanted to generally know is, does anyone have any good reasons why we shouldn't clear up this term and make it clearer?
No, I agree, and I say go for it.
Yeah, I also agree. I think the term query is very confusing.
Happy to help make that happen.
Oh, hell yeah. Yeah, this is one of the things that pains me every time I am doing like an editorial pass and I'm trying to merge something in. I just like strain myself from going in deep on this problem because we did not do a great job in the original authoring of the spec, and it's pretty pervasive. So I acknowledge that it's a pretty big project to take on. It's a little bit more than just a find and replace. In terms of my recommendations for next steps, I really love how in the RFC issue you teased out like the different ways in which we use the word that maybe can lead to a mapping of like, if it shows up, if you see, you know, query execution, then you should replace it with this term, and that can give us some tools to at least talk to make sure that the terminology is correct, and then hopefully gives you the tool to do a reasonable find and replace. But I'm more than happy to review as needed, both in process pieces or like actual pull requests against the spec.
Fantastic. That's all I have.
If you're volunteering to be champion for this one, then I'll do what I can to support you.
Excellent, thank you.
Just a quick note, if we're changing terminology in the spec, we also need to update like in other places, like reference implementation and stuff. If Benji would be overloaded with like text changes, if just ping me and I will try to create matching PR for GraphQL.js.
Awesome. Thank you, Ivan.
One other note, given that there are going to be multiple places that these terminologies would have to be changed, it would be helpful to have a list of terms and definitions document.
Yeah, I completely agree. I think my plan will probably be to build that first, as Lee was suggesting, basically. Run it by Lee and any other people that are, very, very familiar with the GraphQL spec, and make sure that those are all solid. And then they'll work basically as a tool for me to actually translate the spec, but also for everyone else to translate their own documentation where they may have previously been using the old spec terms, how they can use that turn that into the new spec terms. But yes, that would definitely be an aim.
Nice.
Quick idea. Since we probably should have this definition inside the spec itself, maybe we can, in SpecMD, maybe we can create syntax for definitions. And then build Appendix C. We have Appendix A, Appendix B, and that's Appendix C as a glossary, and reference it back to definition. I think what definitions should live inside the spec, not as separate documents.
Yeah, I agree. I was going to mention something similar. I think it's super worthwhile to have an in-process document that maps those out. That's like a living doc. That's something that's easy to provide feedback on top of. But I agree, having something that can be a source of truth in the spec would be super valuable. I don't know exactly what that should look like. We have some element of that in that algorithms and portions of the language are well defined and then show up in the appendix. But I really like the idea of being able to demarcate a term as being like a term of art within the GraphQL spec that has a definition. That way they can all be automated and collected at the bottom in the appendix. That could be pretty nice. But that might be a follow-on step to this. I think I wouldn't want to overload too many things on top of this one idea. Any other thoughts on querying the query? Benji, I assume you wrote the agenda item that way just so that you would get me to say it multiple times.
Absolutely.
All right, cool. Well, this is exciting. I'm glad we're putting some thought into making the spec easier to read and understand. We can move on to the next topic, introspection shortcuts. Terrence, I'll hand it to you.
So it's kind of a simple contribution here. Basically, it's just a proposal to add name type and punctuated name to the introspection type. The issues that I was always facing is that it's difficult to kind of query the GraphQL endpoint to get an idea as to what this scheme actually looks like when you're not fully familiar with it. If you're trying to do it by command line or something like that. So I'd like to add in these fields here to make it easier to do it in one request and also get the information in a more readable format. So I'm not sure what exactly I need to do here, but basically it's just a request for comments right now. So I'm not sure if there's any questions or.
Anybody have thoughts on this?
I'm a fan of this. I've using the introspection query quite a lot. The of type does seem quite redundant when we have already a concise language that can express the nested non-nullability and array syntax. It would be very nice to be able to just say this field is, square brackets, exclamation points, and know exactly what it is without having to query that depth of object. I think it's a very simple thing to add to introspection. The rules for it currently are very clear. If we were to add other types of things in future, and I don't know what those would be, but maybe things like tuples, That may be a reason that we wouldn't want to adopt this right now, because it might complicate the syntax of how we would expose that. But in general, I think it's a good idea. So I would like to come up with good reasons not to do it if we decide not to go ahead, basically.
The reason why I wanted other people to talk first is I'm going to be the wet blanket and ask for, you know, proof that this is important to unlock something in the GraphQL space that can't currently be done easily. I buy that the introspection API is cumbersome. I don't know if that's the most important problem for us to be solving, or like even one of the top ones, given that the queries written to them are almost always automated by tooling. And the thing I'm most worried about is limiting, like taking assumptions on the current structure of introspection, baking those assumptions in these in a way that will block further development of the introspection API. I don't necessarily think that means that we can't do something like this. I think that just has to be strongly considered. So I actually really like Benji's sort of counter straw man, which is imagine a inlined type, like an inlined tuple type, something like that. How would that change how this works? I can imagine something like a punctuated name or a formatted type kind of field, maybe being able to work, but maybe the placement of where that you put that might differ. Named type might get a little trickier in that world, but I kind of want to pose that as it's a bit of a thought experiment. What do people think about that?
Yeah, I think I agree with both you and Benji. Like, I think on balance, this is probably the right thing to do, but we need to do a lot more. I would like to see a lot more kind of depth and explanation to the RFC of, like, you know, possible implications and how this plays out in the future before we just merge it.
I'm personally against bringing any SDL inside introspection, because we already have a precedent, and it's actually a big theoretical issue, not a big practical issue, but we have a problem with custom scalars, because default values for default values already serialized. So if you specify default value for custom scalar, client doesn't have access to serialize and parse literal functions. So it cannot parse default value. And it's happened because instead of JSON data structures, we use strings. I'm not saying like it's direct parallel, just example of what happens if we bring serialized things. Another thing, it's basically mean every time we change something in SDL, scope of breaking changes become bigger. It's not isolated. So I'm totally for, if we figure out how to do it properly, I'm totally for this change, because right now we have hard-coded inside the introspection query, we hard-coded 7 or 9 levels of deepness, and some people actually hit these limits, and it's a problem. But I would be totally against like making it as a string. What I would suggest is to think about arrays. So instead of like deeply nested, maybe we can figure out how to return it as array. Since for array, you don't need to write deep query. So this is my position. So I'm not really like stringified version, but I'm totally like for this change.
Perhaps it'd be helpful to reframe the discussion to focus on the problem of finite queries for introspection, and then go from there and see, okay, this specific problem, can we make an introspection guaranteed and finite, and then explore what are the options.
That's much more interesting to me. So, Stephen, if I'm understanding you correctly, you're worried about the idea of being able to write an introspection query that might end up, I don't know, somebody has a non-nullable list of 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 a thing in like an extreme corner case. And then some tool's introspection query just happens to not go one level deep enough to represent that, and ends up breaking in a hard to understand way.
Especially since a lot of production schemas now have depth limits in what you can query. And so they may end up, you know, if the wrong combination of things, you may end up making your query unintrospectable that way.
Amazing. Then, you know, I don't know if I'm as strongly adverse to a stringified form as Yvonne is, but I certainly understand the concern. But that's certainly interesting. You know, how might we consider reducing the depth? That problem statement leaves us in a lot of potential different directions. There's also, at times in the past, we've brought up the idea of a recursive query by being able to spec a fragment that can refer to itself. And right now, the only reason that is not allowed is because we don't have good tools for blocking infinite recursion. But I've always sort of seen a viable solution to the like infinite depth problem to allow recursive fragments in a controlled way. So that might be one way to handle this, but it's certainly not the only one. But Stephen, I kind of like your reframing of the problem to bring it back to like an actual tractable problem that has been a pain point beyond just convenience. Any other thoughts?
So I guess I'm not exactly sure where the infinite recursion is coming in. I mean, this is being added to a type, which you're eventually going to reach a concrete type. The several nested of types was an example that I have in the RFC. So I'm not sure where I'm not very familiar with the GraphQL spec as of recently. I think I last read it about a year ago. But so it's, I mean, are there dynamic types coming into play or something? I'm not sure where that's coming from.
I don't think in introspection itself there are potential problems, but imagine we introduced recursive fragments as a solve for this particular problem, so that you could write out, you know, every time that you find yourself asking for the type of a thing, you can just reference, give me all the fields for this type, and that can go recursively in all the directions it needs to go. Then great, this particular problem could be solved, and we know for sure that it's not gonna do anything harmful. But if you introduce that as a general tool, then people will use recursive fragments in other parts of your query. So imagine if you have a bidirectional relationship between two things. You know, you're a music API and you want to know the artist of a particular song, and then you want to know the albums that they published, and then you want to know the songs on that album, and then you want to recurse from there back to the authors of that particular song. You could write such a query that will never end. It will just crawl that loop of the graph in a circle forever and DDoS that server. So by requiring queries to be explicit, you can know a priori the maximum potential span out of that query. And recursive fragments make it difficult to control that. So that's the reason why we've not allowed those in the past. I'm not suggesting necessarily that that's the path that you should take for this particular RFC. I think having an alternative is really valuable. But one of the things that has worked really well for these RFCs in the past is to start with like a really clear definition of the problem that we need to solve, and with multiple examples of that problem, and then like the landscape of potential solutions, and then we start to eliminate solutions for various reasons. So we could eliminate the recursive fragments one for like past precedents would be a reasonable reason to eliminate that if we feel strongly that the previous decision to not allow that because of this recursive fragment DDoS problem is too difficult to solve, then like, cool, let's not follow that path. And if we think of a separate path is more viable, then we'll do that. But does that context help answer why the recursion could be a problem?
Slightly. Just so I'm on the same page, though, you're not suggesting that there's an infinite layer of nested lists and non-null values, right?
Yeah.
Okay.
Introspection, I don't think should have a recursive problem necessarily. Any other thoughts within this proposal? Cool. I'll suggest some next steps. I marked this pull request as a straw man proposal, and so I'm glad we're talking about it. I think next steps for me is to start to answer some of these questions around the concerns, to tease out cases where this could break, future possible additions to the introspection schema, and what might be harmful to those. Hopefully we've managed to capture a couple of notes around some of those concerns already, so you can kind of look to those to address them. And then comparing this potential solution path to other potential solution paths. So usually our RFCs focus around a problem to be solved, and so we want to evaluate many potential solution paths. And so this is a good potential solution path, but we should make sure it's the right one out of other various possible future paths.
If I may, real quick, regarding the recursion, wouldn't a developer or a tool that's trying to query the full the full schema, wouldn't they already do that? Because I mean, by doing all these nested types, especially with the n+1, they have to keep making recurring calls to the schema to get that information there. So it sounds like it would be doing more work by not doing this, if that's what their end goal is, to get the full schema.
Kind of. So you can't write an infinite recursion. That would require infinite characters written in the query. So by making the length of the query related to the length of the potential query execution, that limits any potential infinite recursion. So recursion is not what we're worried about. Infinite recursion is what we're worried about. And but you're right about the fact that the query itself repeats, multiple times in order to get to the full depth of these. Then you're certainly right that there is recursion happening.
I'm not sure where the infinite recursion is coming in, though. That doesn't.
Infinite recursion will happen whenever you have a cycle in the graph of your objects. So going back to my example of a musician with albums that have songs and the songs have authors, that's a cycle.
So I guess I'm not seeing why it would jump from there, because the nested layers are only for lists and non-nulls. You would eventually reach an artist or something else. So it's, I guess
in this particular example, yes, but not in all examples. So remember that anything that we add to GraphQL can be used not just for introspection, but for any query. So if we were to add something that allowed us to do infinite recursion, then people will use that tool outside of introspection. And there's probably lots of very useful cases outside of introspection for a tool like that, but we'd have to make sure that we protect against infinite recursion DDoS attacks.
I think the confusion here is the infinite recursion is being talked about in the context of an alternative solution, not in the context of your solution, Terrence.
Okay. Okay.
Yes.
Thank you.
Yeah, your solution does not introduce infinite recursion.
Okay. That's what I was. Okay. Thank you for clarifying that.
Oh yeah, sorry about that. Yeah, I was talking about an alternative path being introducing the ability to do recursion, which is something that we don't currently have. Any other thoughts on this topic before we move on? All right, let's talk about input unions. Vince, do you want to kick us off?
Yeah, sure. So a few of us met a week ago to talk about the various solutions that have been proposed for the input union. And it was very lively and interesting discussion. We reviewed the entirety of the RFC. And we have a couple set of notes about the sort of overall shape of what happened that I can quickly review. So solution number 4 didn't have a champion. So for the most part, that one's off the table. It would probably be helpful for anyone who wants to pay attention closely to pull up the RFC document. It's linked to in the agenda. Solution number 4, let me scroll to it real quick, was structural uniqueness. And that had a whole host of complexities that kind of meant that it was going to put undue burden on schema authors and put some major restrictions on what you could actually model, amongst the other issues with it. But for all the other solutions, we didn't strike anything else off the table, but we did start thinking about a new solution, number 6, that would be a merging of basically solutions 1, 2, and 3. Basically a Frankenstein algorithm that would do a set of different evaluations to figure out the eventual input type to do the discrimination process. We don't have a final formulation of that solution yet. It's sort of still being thought through. But there's aspects of all 1, 2, and 3 that people like, that we're hoping to be able to merge together. There's also a good amount of talk about one of as potentially a solution for input union and also potentially on its own. There was some interesting discussion of using one of both in input and in output, which is an interesting set of things to think about. There's some follow-up that may or may not have gotten completed yet, but Lee's going to do a little to write up a concept for this merged solution, number 6. I am going to be doing I haven't gotten to this yet, but some research on what literal values might look like, because solution number 2 involves the usage of a literal value instead of the explicit type name for the discrimination. And then Benji's going to be doing some thinking about this one of and ways that it can be used to express input unions or usage in the output. So that's like a rough overview of the discussions that happened. I would like to open it up to perhaps anyone else that was in that meeting wants to cover something I missed or expand on any of the topics. There's lots to talk about here. I have one particular thing to talk about with regard to literals, but I'll open it up first.
Yeah, I was at for like the first 3 quarters of the meeting, and I just wanted to kind of frame it in a slightly different way as well. But I find easier to think about, which is that we basically realize that there are 2 broad paths forward, either a tagged union approach similar to one of, or a discriminated union approach, which is kind of options 1, 2, and 3. And so that's why we're tackling a new option 6 as kind of the combined ideal approach for the general discriminated union solution.
Yes, and there sort of one of the comments in a recent PR or issue talked from a person doing some programming language research, was commenting on about how most of these solutions are essentially the same underneath the hood. And we sort of realized that in a way that's pretty true. We have the task in front of us is discriminate between types, right? And then there's a few mechanisms that could be used. You could use the type name itself. You can use a literal value, or you could use nothing. Those are the vehicles for discriminants. And then there's mechanisms that we can use to resolve ambiguity. If we don't have a match, we could use something like a default. We could use something like the order of matching, and we could use some like a uniqueness, some kind of structural analysis. So that's kind of a broad set of like what it is that these solutions could contain. And so with that in mind, we started down the path of like, okay, well, how could we merge these together in a way that gives the most flexibility, but also retains like a lot of simplicity if a schema author just wants to, has maybe an easier domain to model. One other aspect that we kind of went over is where do we put the power to discriminate? Is it in the specification with like strict validations and restrictions on what can happen? Is it in the server where the schema author decides a lot about how the discrimination might happen? Or does it wind up in the client? So that's another sort of axis that we talked about. Lee, perhaps do you want to like walk through the little rough sketch of what the merged algorithm might be? It was in your notes. I don't know if you have that.
Yeah. Before that, I'll also add one thing that was really valuable is we started actually by reading through all of the solution criteria rather than jumping straight to the various proposals at hand for the solutions. And that was super useful because it allowed us to both add color along the way. We both like updated some of the objections, added new objections. We tweaked some of the criteria score, although we didn't fan that out across all of the places where those are visible in these docs. We also even eliminated some of them where they were potential solution criteria, but we were unsure as to how important they were, and it gave us an opportunity to talk through it live. So I thought that was a really useful way to spend that time. And I think we have a follow-up action to make sure we go back, and I was taking live notes in the spec itself to try to make sure we wouldn't lose all that stuff, but not everything ended up landing there. But to give a little bit of color on a solutions number 6 in here, I think it would probably then cause us to at least eliminate 3 in favor for 6, and maybe even also eliminate 1 and 2 in favor for 6. But the idea is that, so solutions 1 and 2 require an explicit discriminant to discriminate between the various potential types. And then just how they do it differs. So the first one requires that you provide a dunder type name field. And then that would just be a string that matches the name of the type that you expect your input value to be. And then the second one introduces literal types. And then you just have to, when you specify your union, you have to also include what field contains a literal type that is the discriminator. And then presumably we'd have some schema validation that ensures that your discriminator is in fact valid. Both of those are completely viable ways to do discrimination. And in fact, there were elements of both that we liked. But the problem was with both an adoption strategy. So for people who are already accepting a input object and then want to convert that input object to an input union, going from not just requiring a discriminator to requiring a discriminator means that you can't do that. So that was one way that these two paths were a little more restrictive than we wanted them to be. The other cases were coming up with examples where there actually was structural uniqueness naturally occurring in the input union, and then requiring additional discriminators felt like an unnecessary burden that we were asking schema authors to take. And so then again, in those scenarios, it felt a little too burdensome. But then in the solution number 3, it's kind of the opposite. Solution 3 looks only to the order. So it just kind of walks through all the potential input unions in your order and then checks them one at a time. And in the case that they are structurally unique, then you can kind of know which one of those is going to end up matching. But in the cases where there are ambiguities or overlap, then the tiebreaker is just whichever one appears earlier in the union. And for scenarios where the input is dominantly structurally unique or almost always structurally unique, then this works fine. But in the case where they're really not, then this does not really work fine. And you really want something to be a discriminant, and you want a tool to give authors to specify that discriminant. And option 3 doesn't come with that. So I think a realization with an option 6 was something that, like 1 and 2, provided tools for a discriminant, whether that was a dunder type name as a default, or allowing you to explicitly suggest a in schema discriminator field that use literal types, but to not require them. So they're there as a tool for schema authors, but they're not required. And by making them not required in scenarios where structural uniqueness is guaranteed, that's a viable path. In cases where a schema evolution and adoption from existing schema is more important, then that's a viable path. So there's downsides to this approach too, and not requiring it, because it offers scenarios in which case you could end up with a schema that can't be evolved. So I don't know if we're sure that that solution is the perfect solution, but I think it's a pretty interesting assembly of these previous ones, and maybe even a way to be able to use some of the tools of 1 and 2 in more places than just input unions.
Right. So the rough algorithm is check type name. If it's there, you're good to go. If not, walk through a few steps of determining the ambiguity, using these ambiguity resolution techniques.
Yeah, kind of the fun part about the algorithm is that the algorithm remains the same as number 3. It just says check them in order, and the first one that matches wins. But if you think about it, that algorithm also applies to solutions 1 and 2. It's just a slower version. It's not the fastest possible algorithm. But if you think like check the first one, if it doesn't match, check the second one, and if it doesn't match, check the third one. If it matches, you got to win. If you have a discriminator, then it's obvious that any ones that won't match are going to fail, and there's only ever going to be one that matches. But that discriminator gives you a tool so that you can replace a O of n algorithm with an O of 1 algorithm. So I think the cool thing here is that the algorithm remains the same. It's just check them in order. And as we do with other algorithms in the spec, we'll suggest if there are an implementation specific faster way to do this that's observably identical to the algorithm that we specify, then we encourage it. And we would probably also suggest cases where that would be the case. So if you did provide dunder type name, then there's no reason to check them all. Like you should just look at the value of that dunder type name and jump straight to that type and check it. Or if there's a literal discriminator, then like check the literal discriminator before you check other fields. Or maybe even build a hash map table and look it up that way. So there's plenty of ways to make the actual checking the resolution of these input unions fast, but the algorithm can remain quite simple.
I'm worried about one thing about error messages. So if we have like algorithms that use underscore type name, structural uniqueness, and all other things, error message would be pretty big and confusing. And if we try to do it user friendly, we need to do something like a flow or TypeScript error. In a sense, we need to explain ambiguity. So I'm like right now looking at criteria, and I'm not. Yeah, I'm like, what about adding criteria error messages? Because like complex algorithm create confusing error messages. And it's not only error messages from a server, it's also error messages inside IDE. So when you write query in graphical or in VS Code and you put your mouse on curly red underline. It will give you a big box with multiple options. So
it's a great point. If Yvonne, if you can think of specific examples where you're worried about error message clarity, that would be super helpful. Feel free to pull request against that or open the issue or whatever's easiest.
okay.
But I like that idea.
It's action item for me to add criteria.
So one aspect of the literals that I have been thinking about, I haven't been able to do a ton of research on this, but the way that we had sort of been specifying them is, say you pick a field that will be your literal discriminant. We'll go with our animal example, and so to adopt an input union, you would theoretically go through each input and add this field with its literal value. So, you know, cat input would get, you know, species cat added to it. Now, that introduces some kind of strange things in that the membership in an input union sort of forces a change in the structure of the input itself, right? So we're adding this field that say you have added an input to like 3 different input unions for whatever reason, like do you map them, do you change the field name so that they don't overlap and collide, or how, you know, how do you structure this in a way that doesn't get kind of complex and mean that there's some aspect of the structure of the input that has to do with some other thing defined somewhere else. So one of the ways I was thinking about kind of resolving this is this thought experiment of what if the input union definition itself contained all of the structure necessary to describe it, rather than putting any information in the individual inputs themselves. So the input union could look more like a type, say, that it would be able to configure, here's the field that will be the discriminant, and then it will map the value of that field to the type. And one of the nice things about this is it sort of, you model the under type name, you could model it the exact same way, just with a you know, a map that's from this thing to this thing, the like A to A. So a quick sketch of like, I'll just put this in the chat maybe, and it won't look, it'll look maybe a little weird. Real rough sketch in the chat there. So you're defining the input union animal, and then you map, say, discriminator. There's an error in that actually. But this opens up like a way for us to resolve some of the problems of this, and you could have different literal values, like a multiple literal values mapped to the same type, where we wouldn't be able to model that very efficiently or very well without collisions if the definition is in the input itself. Can I edit an old chat here? I'm gonna put a quick revision to that. Yeah, that's the under type name. It would be expressed very literally just by cat input to cat input. So this is the rough idea of what I've come up with to try and resolve some of those collision potential problems with literal values, and removing the knowledge of the input union from any of the input types themselves.
Yes, so we discussed this solution with Benji before a RC process, so it was just in a chat. And Benji came up with good a problem with this approach. Basically, you restricting field. So you you cannot add field with the same name to members. And it's actually like, I think it's actually like a bigger problem in a sense, because in many applications, input types are generated from something, from schema, from database, from something. So if you basically, when you after in schema and you choosing a name for discriminator field, you limiting all the members in using that field. And if members generate from somewhere, like it's not really obvious restriction. Even like when you read in schema, it's not obvious you cannot use this name because like input union definition is somewhere and you just write in this type. So I think it kind of similar reverse problem, but in a case of constant being specified inside input type, it's more explicit and it's more like debuggable. It's more like
That's a good point from Ivan. I don't know if it's a deal breaker for this approach. I kind of like how explicit it is, but it might need something more to limit that error path. But certainly, it may be easier for us to dig through actual code examples in a GitHub issue. But
yeah,
this feels like a good start to the work that you were taking on to investigate literal types in more depth.
Yeah. Yeah, maybe it would imply, yeah, that some kind of schema restriction. It reminds me of interfaces which validate like membership of field members to make sure that they match the interface. So it's in that shape of validation that would have to be added, and yet it would be a minor restriction in what could be modeled. Benji, maybe we can look, do you have anything to offer with regard to the one of? Any thoughts?
Yeah, so we were discussing how the one of models some external data sources more directly than the ones that we were looking at currently, because some of those already use this kind of tagged or wrapper approach where you have an object that wraps it with a key that indicates what the type of the thing is. We also discussed a bit about how that may also be appropriate when matching those external sources for output types as well, and may also have other uses. Lee brought up some interesting history where it was actually considered early on that this might actually be the shape of unions in GraphQL, but in the end they went in a different direction. So there may still be value in it. One of the main issues is, of course, that now it gives two ways of doing the same thing. It's not necessarily the same thing. They are different, but are the differences enough to justify its existence? That's something that I'm going to be digging into whilst I research this topic more. But it could well be that it is a sensible solution, or it might well be that these new solutions, like solution 6, for example, get rid of the need for this. So yeah, I'm going to be doing a bit more research on how this might affect both inputs and outputs, and potentially even arguments as well, if I can get that far. So yeah, some interesting discussions going on.
Yeah, part of that historical context was when we were originally looking at unions, we had a very similar kind of debate that we're having now, but GraphQL was much younger at the time, about whether we wanted a discriminated union or whether we wanted a tagged structural union. And we decided that the form of the output was more important than the form of the query itself. And that led us to the discriminated unions, using type name to discriminate. But it certainly doesn't have to be the only way. And I know there are people who are using a structural union approach, even though the query doesn't guarantee that will play out the way that they hope that it will play out. They just have sort of a contract with their clients that they know they should, they should expect to never get more than one field back. I think there are even a small handful of cases at Facebook that use that pattern. It can sometimes be really useful. So I can certainly see a case where having two ways to do this is reasonable as a final output from this discussion, and we might want to backtrack that to output unions as well, because the structure of the data itself is actually pretty different. Any other thoughts on input unions? Questions? Great.
Yeah, I would say we talk about doing another one of those focus working group meetings again.
I think so. Yeah, doing one ideally between now and the next time this group meets would be best, but certainly sometime in the next month or so.
Yeah,
would be awesome. I thought that was super valuable. It's a good forcing function too to get us through the action items that we have.
Yeah, I'll start a Slack thread again, and I mean, possibly the exact same pattern of 1 week before the next meeting or something like that would be sufficient.
Yeah, that's probably a good bet.
Do that.
Sounds good. Okay, let's hop on to our next agenda topic, defer and stream arguments in payload format. Liliana and Rob, I'll hand it to you.
Hey, so we just wanted to go over kind of the high level of where we're at with defer and stream and what we're currently thinking, and kind of get feedback as we work on the spec and make sure that we're going in a direction everyone agrees with. So I have a PR to update the RFC with the details, and so I can go through it a little bit. I can put a link in the chat so you can follow along. Yeah, so for defer, we have an if argument that's a Boolean, and that's just kind of saying, allowing you to control whether something should be deferred or not. If it's not there, it's going to be deferred. If it's there and it's false, it won't be deferred. And then we have a label, which is a string argument, and that's going to be used by clients to understand when the responses come in, what was the trigger of that response. So both of these arguments are in both defer and stream, and the label will get passed through into the payload for whatever triggered the defer and stream. And then for stream, there is an initial count argument, which is an integer, which is just telling the server how many items should be in the initial response. And then as far as the payload format, the first one is going to match what is currently in the spec for a GraphQL payload, with the only fields that are deferred are not going to be there. And the arrays, only the number that are in the initial count would be in the array that's returned. Then each payload after that is going to be an object with the label that corresponds to what was passed to defer and stream, the data that's coming, and then path, which I think is a concept that's already in the GraphQL spec, which just tells you an array of keys that point to where in the initial payload this data corresponds to, and is final Boolean, which will let us know if there are more payloads coming, and then any errors that were encountered while executing. And then I guess one more note that we wanted to bring up is that we're saying that like defer and stream it's highly recommended that a server follows them, but it's going to be in the spec as a should instead of a must, which in the advanced cases of the server having like a better idea of how like maybe it could be more performant to not actually stream or defer, it will allow that, and kind of keeping things flexible in the future. So we do want clients to be able to handle a case where they say something is deferred, but it doesn't actually come back deferred. So that's what I have. I guess I want to know what everyone's thoughts on that are. I saw a couple comments from Matt about his final.
Yeah, so just as like high level comment, this RFC basically matches exactly with how our client worked as of about 2 weeks ago. And reason to have RFCs being used in production before they hit the spec. We discovered at Facebook, yes, our client works perfectly with servers that always indicate whether they're defer streamed or not. But when we tried to point that client at basically a not Facebook server that matched the current spec or matched the yeah, I don't actually follow the defer stream spec, we errored because we never gotten his final. Because the initial payload is the final payload and has no indication of whether it's the final payload because it's like a spec compliant response.
That jumped out to me as well. My sense is that if we have a Boolean there, it should default to false rather than true. My suggestion would be, rather than saying that this is the final payload, say if we expect additional payloads in the future.
Yes, and that's exactly the change we had to make for our server. Unfortunately, because we actually have our defer string client in production as it was, that also meant even though we could fix our client so that it can now work with like or the current version of our client as of a week ago can work with the spec compliant servers, our old clients cannot, which means we're basically stuck always sending is final, whether it's true or false. And we don't want the open source community to end up with that, with being required to send as final.
Yeah, that definitely makes sense to, so I'll update this document to kind of flip it, as you said. And
this is a small stylistic thing. Oh, sorry, I interrupted you. Go ahead.
Go ahead.
Small stylistic thing, we often use camel case rather than underscore case.
Yeah, I was curious about that. So I think we can definitely change that too.
Cool. There are very few cases where we have in spec definitions for these things, but they're often camel case when they are. So it would just be good to be consistent. I also had a general question about label. That's something that's pretty new. I can see that being useful, but I see that it's required. Can you tell a little bit more about the purpose of label and why that's needed in addition to path?
Yeah, so it's not, there could, for example, be two deferred fragments on the same object, and then they would have an identical path, but which fragment they came from would be different. So it's a way for clients to understand that. I guess that it doesn't necessarily need to be a required argument, because maybe your client doesn't really care, or so I think loosening that to not be required is a possibility, unless anyone thinks otherwise.
I think it may be, it might have to be required. If so, especially with clients that can send multiple requests. Basically, if you have a client that can have multiple queries open at the same time, you could have the same path and not know which one is. So it's basically the same problem you mentioned, but you could actually be executing two documents and like waiting on responses for two documents at the same time, and you need to know a way to differentiate the streamed responses for one versus another.
Label isn't going to do that for you though, right? Because you could have two responses that are independent and therefore could have labels that overlap. You could come back with things that are the same label, different paths. Either way, you need to know, you need to be able to associate payloads from one stream of responses from another stream of responses.
Right. I thought that was, do we make label required or not? And that would be, I think, an argument for either making label required or making label or changing the name to be like execute or operation name or something like that.
Oh, this seems like a very different thing because you can have many streams or defers within a single operation.
Yes.
And each of those would have a unique label within that operation. But do we need to also have the name of the operation that it came from in the payload? I mean, you could also execute the same operation twice, different arguments or something like that at the same time. So is that enough? I think this is, my pitch would be that this is something that we don't solve at the GraphQL spec level. Like that should be, your network interface should be able to know the difference between payloads coming in that associate with one request versus a separate request. That's just stream deduplexing.
Yeah,
it also seems going. Yeah, it seems the Rob's first use case where like within the same query, like under the same scope, you could have multiple defers. I think for clients who are like more like fragment oriented, it seems like required, but we cannot assume like all clients behave in this way. Like there are simple clients who just like given a payload, as long as I know which path I merge it into, I'll just merge it and I'll be able to vend the data. So yeah, I'm not sure if we want to like...
I can imagine making, I can see why labels is super useful. I imagine it would make more sense to make it optional as per the spec. But then clients that want it would either automatically generate it based on, the position in the query or what fragment they're found within, or they ask the developer to fill that in and the client requires it. So the client, when you're doing your compilation step or whatever, or a linter step, that client points out that it requires the label because it relies on it coming back.
Which would seem to indicate that we label the server, if the client requests a label, the server must come back with that label.
Yeah.
Okay, so it is required to be in the spec. Your server has to comply with the label, but if the client doesn't talk about label at all, server can do whatever it wants.
That's what I would suggest.
Yeah, I think that makes sense too. I'll definitely make those updates.
I may have missed something here, but I'm a little bit confused about the results of streamed results coming through from different fragments. In normal GraphQL queries, the fragments would be merged effectively on the server side, so the client would only ever see the end result of both of those fragments. And I think if you're allowing two different streamed responses to come from fragments where one set only has one set of fields and another set only has the other set, that's going to be quite a divergence in behavior from what we currently have. Is that what we're proposing here?
So if you have two fragments that are both deferred under the same object, they could have different fields on those fragments, and you would not want you wouldn't want to combine them together, because if the fields on fragment A are slower than the fields on fragment B, you want to get the data for fragment B as soon as you can. So there is like the possibility of overlap where the same fields are there and they could get returned twice, but it is kind of a change in behavior where not everything is getting combined. Is that your question?
Yeah, that is my question. So I think where I'm struggling with this is potentially, say you have non-nullable fields on both sides. If you were to do something like code generation of a current GraphQL document, you would know that the results that you're going to get back would have all of those non-nullable fields, even where like 3 of them are specified from one and 3 from another. In this solution, you'd effectively need to generate the types for those separately, which then means you've effectively got that initial payload, which merges the 2 fragments as one set of things, but then the deferred results are effectively then coming in as 2 separate streams, which I think could get challenging. I mean, this is the first time coming across this, so I don't have very well-defined thoughts on this, but it does seem to be problematic potentially.
Yeah, I have experience here. So yes, it's very problematic for type model based clients, like a client that says provides schema types directly to the user with like type safe arguments. That type model client would now need to say, oh, are any of these fields being deferred in? But that's already a problem for type model based clients, because you might not request a field that is a non-nullable field. For fragment based clients, so there's like 2 levels of fragment based clients. One is like operation level, where you know, okay, I'm getting one operation, I know whether this field is going to be in the operation or not. And there you again have to now update that client to be knowledgeable about stream and deferred fields, and it's kind of messy. Which is why, yeah, it does get messy. For clients that are truly fragment based, which in essence say, oh, when I hit this fragment boundary, I have to either do a conversion or I have to somehow like indicate I'm no longer fragment A, I'm now a model representing fragment B. It actually is very, very clean, because so long as you have the label, you can say, okay, was this specific fragment fulfilled? And if it hasn't been fulfilled by the response yet, then then when I try to convert into that, I just give a null for the entire fragment. And all the fields, so I don't have to change the types of the fields inside that fragment. And when we do get the deferred response back, we know that all of the fields match the schema level types, so we don't have to do anything special. But you do have to add special handling on the client at the fragment level boundaries.
Okay, so I have a separate question. Is there a potential issue here with too much branching going on? So if you, for example, say you defer 3 fragments on the same type, and then they have, say, a relational fetch, and then there's things that are deferred on that. Previously, you'd effectively be returning, you know, a particular structure of objects, but now at that base level, you're going to be returning 3 objects where there was previously 1. And at the next level, for each of those 3 objects, you're then going to potentially be returning another set of branches from there. Could that be used as a, you know, denial of service or some nefarious way of compromising a server? Not compromising, you know what I mean, interfering with.
Yes, it probably makes a DOS, a denial of service attack, like more likely with the query that you're using, but we've always allowed you to create queries that branch a ton and like get this user, get their friends, get their friends of friends, get their friends of friends of friends. Like you've always been able to create that. So it does potentially exacerbate the problem. On the other hand, it also gives your server a way of, because you have these well-defined boundaries, your server now has some control and can just, like, you can have a server that says, okay, because this took too long to execute, I'm closing out and not going to return the fragment. Like I'm not going to keep executing, even though there might be more data. Like we're closing out in order to prevent a denial of service.
Just quickly, does anybody have any questions about the type model approach and why this doesn't introduce any new hazards here? And also the DDoS question, has that been addressed to everyone's satisfaction? I'm curious about if there are any other concerns.
Just a meta point, I think it would be worthwhile to document those concerns in the RFC doc, just because even though we might be able to talk through how to address those and whether they're real problems or not, I expect that this will just be a thing that comes up over and over again. So having like a clear articulation of all of those in the RFC could be super useful.
Yeah, I'll lay those out in the RFC.
Thanks, Rob.
Do you want to discuss the point that Lee mentioned in the chat about overlapping fields?
Yeah, just to speak to this, understand comment, and maybe I'm coming up with something different from what Benji was talking about, but this was something that was always kind of an open question to me, is when you defer a single field, then it's pretty obvious what that means. But if you defer a fragment that contains multiple fields, which might overlap with non-deferred fields, what's the behavior? And QA answered that for the overlapping fields, they're going to appear in both the original payload and the subsequent deferred payload. That seems like it's the only viable answer. Otherwise, servers are going to have to be doing some kind of complex subsetting algorithm that might not make sense. But if there's more color on this, I'd love to hear it.
Yeah, I'm curious about this too, because having them show up in both would be a fairly substantial implementation change for a lot of servers right now that do a fairly like merging of fragments, merging of field selections before execution happens right now. I know at least the Ruby implementation works that way, and so like moving that to a different layer of the execution would be a fairly substantial change.
Yeah, I completely understand the concern here. And I think this is something that we actually tried if we are able to deduplicate. The fact is that the defragmentation algorithm, both the Facebook implementation as well as the open source spec, is very complicated. So the complicated case here is, so right now the case is, example given by Lee is simple. It's a leaf field. It's a name that returns a string. The challenge comes that if you have a composite field, like say a user object, and then it appears in both fragments, and then the nested fields under the user differs. So you will, in your defragmentation, you will start to need to like traverse down the tree, maybe arbitrarily deep, until you find something that is different. And then you make a decision, okay, that is the thing I need to include in my deferred payload, which is just way too complicated to do. And I think like at runtime, like basically for a server, you go to the database, you retrieve something once and you return client twice. It's more efficient than trying to do this CPU intensive computation of tree traversal and comparing and find out that they're different. So that's the trade-off we made there.
Although presumably this wouldn't be an issue for persisted queries, right? Just want to clarify.
It still is a problem. We still perform defragmentation for persisted query because defragmentation happens at each level, because you could return an interface and then you need to check whether this current object applies to that interface. So that has to happen at runtime.
Right. Okay, that makes sense. It is going to make adoption for at least some implementations quite difficult. So I think that's another reason to also keep this as optional in the spec. Servers should not be required to support defer and stream, at least not in the short term. But
I don't think any server should be required to support defer and stream. I think if you do support defer and stream, you should adhere to some clear behavioral rules. But I expect there will be plenty of servers that don't support them, and that should be fine.
On that note, one question I have is, we've said we want to make this a recommended, like your server should, but is not required. I wonder if we should actually bump that down to your server can. And what, like, should you be able to send queries to a server that doesn't support defer and stream with your @defer and stream? Like, do we require those servers to drop them? Or is it okay for those servers to throw an error and say, hey, I don't support defer and stream, rewrite your query?
I think the argument on the other side of that was brought up on one of the discussion issues we had was that if you are, as a client developer, if you're putting defer in your code, you kind of want a reasonable expectation that the server is going to follow it because of the performance implications that you're asking for. And if it's not like a high likelihood that it's going to be followed, like you might want to write your app in a different way if you know it's not going to be supported. And like, if you have the option of doing separate queries versus deferring some data, then defer is better if it's supported. But if it's not supported, then it's worse than separate queries. And so if you don't know what the server is going to do, you can't really make that distinction when you're developing.
That's a good point. Yeah, I think if the server is accepting those directives, then it's reasonable to assume that it's actually treating them correctly and not just always ignoring them, even if we provide the ability to ignore them in a case where a server thinks that the performance will be best in that case. It's not really ascribing to the letter of the rule there or the spirit of the rule if it's dropping them with no consideration to the performance, just because it literally doesn't have the opportunity to do a stream's response. Also, I expect that if you include defer or stream, that implies something about how the actual network response works. You know, like is it going to use chunked encoding or not? And a server that doesn't support stream might not support chunked encoding either. So my sense is that we can communicate this in the in introspection by, you'll be able to know whether these directives exist or not.
On a slightly related but slightly different note, I'm curious about the claim that defer and stream actually work better for the client than splitting the query, because like at least naively, a split query would execute in parallel across multiple load balanced app servers, whereas a deferred query would execute serially still, and the client would actually get faster responses by splitting their query, even when the server supports defer and stream.
No, the assumption was that you would need data from the first query to make the second query. So it would be a full round trip.
Right, fair enough, yeah.
Or even in cases where it didn't, ideally these can be done in parallel. I mean, a lot of this is making assumptions about what your infrastructure can and can't do, but ideally your infrastructure is handling these in cases where they can be done in parallel. We would hope that very well built GraphQL servers can identify the opportunity for parallelism and take advantage of it. And if that's too hard to deduce, then maybe that's something that we should address in some way. But from first glance, it seems like we should be able to do it.
Yeah, there are a lot of languages with global interpreter locks still, but definitely for the languages that can do that.
Yeah.
Yeah, are there any other points that we wanted to go over?
Sorry, Lee, to be pedantic. You mentioned that you think it should be indicated in the schema if the server supports defer or stream. I think it actually needs to be indicated both in the schema and through the server, because it might well be that the schema supports defer and stream, but the server does not, and vice versa.
That's interesting. That's not something that there's no precedent for that right now, right? Right now, the only way you learn about what a server can do is by doing an introspection query. Or are you talking about like literally the transport being available, like some element of this going out to like GraphQL HTTP?
Well, to give you an example, you can write a GraphQL schema right now with the GraphQL reference implementation, and you can add subscriptions to that, and you can serve it through Express GraphQL, and subscriptions are not supported because, I mean, it will do it as a regular resolve. It won't do the actual subscribe operation. Yeah, that's what I'm trying to surface, basically.
That's a fair point. Not necessarily pedantic. I think we should make it easy for clients to understand what is and isn't available.
Is there a way that we do that now with subscriptions?
I don't think so. Right now, I think the assumption is that if you can see the subscription, if you can see subscriptions in introspection, then subscriptions are supported. It's certainly possible that you can screw that up, but I think that's the assumption at the moment. We could probably do better than what subscription does in the moment. Maybe that's, Benji, if that's a reasonable restatement of your point.
I mean, I'm happy just saying that's up to the developer of the server to make sure that they support everything the schema supports, sort of thing, and bundling those together. It's just thinking as part of the GraphQL over HTTP working group. It's very important to know where we're drawing the lines here, and effectively we're letting the transport layer, the HTTP, and the actual schema, like almost the function call, as it were, because you might take the same GraphQL schema and expose it over multiple transports, and that's quite common. So for example, to expose it over both regular HTTP and WebSockets, where the subscriptions would only normally work over the WebSockets, but the regular queries and mutations can work over HTTP. And do we really want to require people to use two separate GraphQL schema-like instances for that? And yes, maybe we do.
This is an interesting question. Yeah, it's one that I feel like we didn't do a great job at answering with subscriptions. Right now, it's pretty common to have one schema and two different actual network protocols, one to handle subscriptions and one to handle queries and mutations. This, since chunked encoding is a sort of natural suggestion atop HTTP, and that's the dominant way people are using GraphQL, then hopefully this isn't quite as severe as subscriptions was. But your point is well made that we need to make it pretty clear on how clients can learn about what their network protocols can support. And schema might not be enough, since the schema could be shared in multiple places. So that's fair. That it does maybe escape a little bit outside of stream and defer as a spec. Maybe this is something we can lean on the GraphQL HTTP sub-spec work for. But I agree that this is something that the combination of those two things should solve. One other question that came to mind was, right now there is, I don't know if we mentioned it explicitly in the spec, it's certainly an assumption that values that appear in more than one place in a query are cached such that you're not getting like two different values for a single field spread out over time. You know, so if I ask for my best friend's name in one part of my query, and then via some other subpath of the query, I ask my best friend's name again, and they happen to change their name in the midst of me running this query, maybe that's a terrible example. But there are things that change frequently. I don't know, the number of likes on a story post or something that's going to change in real time. If you run a query right now, you expect to come back with consistent values across those fields. Defer intentionally spreads out execution over time, but I wonder if we want to either leave this undefined or apply some rules for how we expect server-side caching to work for like tearing of data.
Is that consistency expectation actually in the spec anywhere right now?
I don't remember if it is.
Yeah, I think we actually briefly talked about this. The fundamental problem is interleaving mutations that happens inside a query. And the way I see it is that a defer and stream query should handle interleaving mutation exactly the same way as a regular query handles it. Instead of saying like, thinking about it's like spreading the execution to a long range of time, we should just think about it as reordering the execution time, right? Like I'm prioritizing one and then delay the later. But the server is still trying as hard as it can to return all of the data within the smallest amount of time as possible. I think if Jaffer is on the line, he can probably also talk a little bit more about like in order to introduce consistency, we've been playing around with the idea of like strong object, fetchable object at Facebook, which I think without those concepts, it's gonna be really hard to describe like consistency in GraphQL or like what that means. So if we can treat that like as a separate problem by itself, I think that would be great. Because it is a problem, I think, if you have an expensive query that just runs a pretty long time, it's going to happen as well.
Yeah, we run into this in production occasionally, and it's just, you know, one of those shitty bugs that happens.
Yeah, just briefly touch on that question of identity, because it actually is rather pervasive. It may even affect the discussion we were having earlier around fragmentation. For example, today when we do defragmentation on the server, it's fundamentally memoization, which is to ensure we don't sort of evaluate the same field twice. It's probably the best way of doing that. Another way of doing that might be memoization, but it's not, well, so A, it requires a lot of memory, and B, it might not really be that effective in some cases because you have the same object that can appear in the graph multiple times, and there's no way of knowing that because there's no notion of describing an identity of an object in GraphQL. And it's often been remarked, of course, that GraphQL, it queries a graph, but it returns a tree, and we don't really have the graph structure in what we return. So just as I want to give some context about that, that's an area we've been thinking about, and it may even be worth, it's interesting to discuss the possibilities that would be opened up by standardizing how we discuss and a unique identity in a GraphQL response, because it could impact the way in which we do defragmentation more efficiently rather than the process we currently do, would open up possibilities to do it by memoization. And furthermore, it would allow us to provide stronger consistency guarantees than we currently provide, which is to say almost none. Because of course, if the same object appears in multiple places in the graph, right, not even defragmentation necessarily guarantees consistency, but identity would allow us to guarantee some level of consistency within process relatively inexpensively. You know, for the length of the time the session's open, we have an in-memory cache of object by identity. So anyway, those are some kind of thoughts, and it's really a question of whether it might make sense to, if not begin the standardization process of identity in GraphQL. You know, I think there's an open question of whether it should precede this proposal. I think we can move forward with these in a decoupled way and then add stronger consistency guarantees after the fact, though, if we were to introduce identity. Is there any questions about that? What I'm referring to?
I support doing these in parallel rather than depending one on the other. And I like the way of thinking about it is this using defer, just like you're already stretching out running queries over time. That's sort of natural. You just get a payload all at the end of that work, and defer is an opportunity to get payloads earlier in that work. So it's not necessarily about querying the same value multiple times over time. I don't know if we have to be explicit about that, but I would love for us to be more concrete about it, and whether identity is a key piece of that, that we do that independently of field and stream, or a defer and stream. And we do it in a way that applies equally to defer and stream queries as it does to not defer and stream queries.
Sounds
Any
reasonable.
other thoughts? Any other questions in general, or comments about defer and stream and progress so far?
Earlier in this conversation, we discussed what if some client never sends defer and stream and the server doesn't support it at all? Should it just drop that? You know, should it just do it without defer and stream or whatever? And then later we were discussing that either through introspection or something on the HTTP protocol, or in some way, the client should be able to tell whether the server supports defer or stream. If you can't determine it before you get to the point of the query, then maybe it should maybe it should go back to the standard behavior of, like, if the server doesn't recognize, like an old server that doesn't know about defer and stream yet is going to probably just ignore the directive. So maybe there's an opportunity to go back to that if somebody who really cares as a client had an opportunity to determine it in advance anyway.
I was working with the assumption that an old server that didn't support it would error out that it received an unknown directive.
So I could just be completely wrong on that. Is that normal to you error out if you don't recognize the directive?
Yeah, I mean, that's true for other directives that servers may or may not implement. I mean, there's the handful of directives that we have now are sort of required that you have to implement them for the spec, but there's only, you know, it's just skipping and including. But for other directives that are optional that, you know, individual vendors will add, certainly if they don't exist, then your query is invalid against the server that doesn't support them. So I like the high level idea that if a server is not going to do anything useful, then it should fail loudly rather than like fail silently.
Yeah. All right, that sounds good to me. I take it back.
Cool.
All right.
Any other thoughts or questions on defer and stream?
I had one, and I'm not sure if this was previously discussed and if I missed it, but the arguments on both named if might be confusing if you're seeing a, for example, defer if false. I guess what I'm trying to say is somebody might look at that and think it says, if this is false, then go ahead and defer. So maybe the name could be more intuitive.
Isn't that the same problem with skip and include? Because if you have something that says include if false, someone would also read that as if false include, but that's actually not what we are doing.
Yeah, then that would have the same issue.
Yeah.
Yeah, I think you're
Pattern
right.
The pattern is unlikely that you're going to be putting explicit Booleans here, right? Like you're going to probably be doing defer if, then some argument that will then give you like runtime control over whether to do defers or not.
True, but the argument could be named as a predicate. I think, like, meaning it could still be read that way. I think overall, I think just consistency here is the strong argument. So that's why we went in that direction. But I agree. I think it could be misinterpreted.
Yeah, and in practice, I haven't seen anybody make that mistake with skip and include. So probably not a big issue in the wild.
All right, I'm in favor of consistency as well.
Well, this is great progress. Thanks again to y'all who've been contributing to this. I know continuous iteration on this is tough, especially since there are only so many examples of trying this out in the wild, but sounds like there's a ton of great action items. Really looking forward to seeing this continue to evolve. That was our last agenda item for the day. Is there anything else that we should discuss before we wrap things up?
I have one small question. I don't know if there's a document on this or not already, but as a contributor to the over HTTP subspec, I don't really know what the process is for this group to oversee or have oversight over the spec generated by that group.
I would love to include that on an upcoming agenda. I think, you know, I kind of view that as a subcommittee almost of this group. Ideally, the final output there is something that the set of folks who regularly come to this meeting have a lot of visibility into. It's an opportunity to get input, feedback, and come to a consensus across a broader set of folks.
On that subject, I'd like to thank the people that did contribute after we brought this up at the previous GraphQL spec working group that then did contribute to the last HTTP spec working group.
Yeah.
Yeah, I agree, Lee, and we can add an agenda item for the next meeting. Just,
awesome.
If I understand you right, the agenda item would not be to have the oversight discussion, but have the discussion about how we oversight.
Yeah, I think both are valid. I mean, what's most likely to be valuable is kind of talking through the current state, collecting feedback.
Definitely.
But certainly the meta discussion is also useful. I know there's both a question about like what's the most valuable relationship between the two groups of people. There's also a question about like the relationships between the specifications themselves. And there's like a separate action that I need to figure out along with Brian about the like specification legal structure of how we handle the two, and whether or not we have to sign like a separate piece of paper for contributing to one versus the other. I'm hoping we can have one blanket paper that we all sign for the spec agreement that we've already all signed can apply to both, but that's still something that I've been working with the Linux Foundation lawyers on figuring out.
All right, thank you.
Any other topics we should discuss before we wrap for the day? All right, we made a ton of progress. Thanks everybody again for a lively session. Talk to you all next month. Stay safe out there. Keep up the good work.
Thank you. Bye all.
Thanks.
Thanks everyone.
Thanks.
Bye.